Today we are going to solve LeetCode number 230, Kth smallest element in a BST. We are given a root of a binary search tree and an integer k. We have to return the kth smallest value of all the values of the nodes in the tree. So in case of BST, we know that the the value in the root will always be greater than the value of its left child, and the right child will always have a greater value than the root value. So we know that in case of in-order traversal, we will always get a sorted array in case of a BST. This is the property of BST. So from this tree, you can see that from this root we will come to the left side. There is no other left child, so we'll start from here 1, then we'll get 2. There is no other child here. Then we'll go back to the root 3, and then there we will come back to 4. So the values will be 1, 2, 3, 4. So in case k is equals to 1, we can return the value 1. Now another example, in this tree, if we use the in-order traversal, we will get 1, 2, 3, 4, 5, 6. So you can see this is a sorted array, and we'll always have the sorted values in case of in-order traversal in a binary search tree. So the output will be 3 because we need to get the kth smallest element of the BST. Here the number of values of k is given at most 10 to the power 4, and the node values could be always positive, and the highest value could be 10 to the power 4. Now we are going to code this. Now we are going to start coding. The idea is to build an in-order traversal of BST. In that case, the arrays will be sorted. So we'll need a vector which will keep all the values in the ordered list. Then we'll call a function. We will implement the function a bit later. We'll put the method parameters, the function parameters. For this function, we are going to need the node, one node, the root node, and also the list, the vector list that will keep the values in sorted order. In case of this in-order traversal, we'll get the sorted array in ascending order. So in that case, we can return the value k minus 1th element of this array. That will be the answer. So now we are going to implement the recursive function for in-order traversal in the BST. So this is the base case. In case the tree node is null, we will return, as this is a void as a return value, so we'll not return anything. Now we have to call the left subtree in case of in-order traversal. So the first parameter will be the left node, and in-order list, that will be always as a parameter. Now we're going to add the value of this node into the in-order list, and then we're going to call the right subtree using the right node of the tree. we are running the code, it's showing accepted. Now you can see we are submitting the code, it's showing accepted. You have to know the time complexity now. This is order of n for time complexity, and memory space complexity is also order of n. Now the previous recursive solution we are going to try to implement in iterative solution. So here we are going to use stack. There we used recursion. Here we will use stack. This way we can speed up the solution because there is no need to build the entire in-order traversal, and we could stop after the kth element. We have to traverse the left subtree first, so we are going to check if the root node is not null, and then we have to push the left subtree, the left node of this root into the stack. Thus the left subtree traversal will be completed. Now we are going to take the root node and from the stack top, and we will pop it from the stack. We have to check if this is the kth value. In that case we will return the value of the node. Now we will do the right traversal. Right child of the node will be used as the next node. This is accepted. Now we are going to submit the code. It shows accepted. The runtime complexity in most cases is order of n, and space complexity is also order of n.